Good morning, dear friends. So, in this video, lecture number 23, we discussed about relative velocity, application of relative velocity. So, relative velocity, you already know that if two bodies are moving simultaneously, then what is the velocity of one body with respect to the other body? So, relative velocity is clear. Now, the main application, that is river main man problem. River man problem. So if we explain riverman problem, so first of all, you understand the question. If river is having a width small d, suppose a river, so the distance between the two corners, that is small d, that is the width of the river. Okay. Suppose a man is at the one corner and want to travel or want to go to the another corner. Suppose this is a man and he wants to go to point A. So if river is not flowing, then there is no problem. The man will directly going from perpendicular to the motion of the river or directly perpendicular to the surface. So they can reach to the next point, that is A. Okay. But suppose if river is also moving, then what will happen? If river is also moving with a speed of VR. So in the river, the man speed is relative to the river. So we have to calculate VMR, velocity of man with respect to river. So here two cases arises. So case number one, traveler cover a distance within minimum time. Cover a distance in minimum time. Minimum time. If a man covers a distance in minimum time, then what he approach? So this is a river. If we want to calculate the river in minimum time, so he directly approaches a direction perpendicular. Suppose this is the man and he directly approaches the river perpendicular. So this is the direction of the man. Okay, but river is also flowing. So river gives the direction in this way. So actually a man is going in this direction. Okay, so this point is clear. Now if a man wants to going from this point, that is A, so actually he is not at point A. After crossing the river, he is at point B. So this is the velocity of man Vm. This is the velocity of river Vr, and this is the velocity of Vmr. So in this diagram, it is clear that Vmr is hypotenuse. So we can simply applying Pythagoras theorem. So Vmr square equal to Vm square plus Vr square. So what is the value of Vmr? That means relative velocity with respect to river. That means Vm square plus Vr square. So this concept is clear. Now, how much time is taking? So this is the distance small d. In relative velocity, there are three velocities in this diagram. So if we want to calculate time, so we can say displacement upon velocity in the direction of displacement. In the direction of displacement. So displacement is d and velocity in the direction of displacement. Here are the velocity Vm, that is perpendicular to the surface of motion. So T equal to d upon V. This is the final answer for calculating time. Now one more question: how much distance the man actually deviate from its original path? So this is the distance capital X. So the same formula, displacement equal to time or velocity into time, but which velocity? That is parallel to the displacement. So here displacement is in horizontal direction. So x equal to vr into t. So x equal to vr into t. Okay, velocity of river into time. Now one more question, that how the what is the angle with the bank? So this angle is also calculated with the help of this angle. So in the diagram we can say tan theta. So tan theta equal to perpendicular upon base. So Vm upon Vr. This is the angle tan theta. Okay. So tan theta is clear to all of you. Tan theta equal to Vm upon Vr. Okay. Okay, friends. Now the case number two. We're talking about case number two. To cross a river in minimum distance and traveling minimum distance. So in the first case, time is minimum but distance is not minimum. So to overcome this remedy, a man wants to travel in this way. So in the second case body, a man travel a distance in minimum distance. So here are the width of the river, that is small d, and now a person wants to come directly to his place. So now for this case, the person starts traveling in a direction like this, so that if river pushes him, so he can move in this way. So that is the velocity of Vm, and velocity of river is in this direction. So the resultant velocity is come to directly in this direction. Okay, so that is Vr, V resultant. So this velocity is Vm, this velocity is Vr, and this is V resultant. So with the help of triangle Pythagoras theorem, we can easily see that Vm is hypotenuse in this case. So Vm equal to Vr square plus V resultant square. V resultant square. So now we can say that V resultant square equal to Vm square minus Vr square. So write V resultant equal to under root Vm square minus Vr square. This is the value for V resultant. Okay. Now we want to calculate how much time. So time equal to displacement. Displacement is d and velocity in the direction of displacement. So here velocity is v resultant. So time equal to d upon under root Vm square minus Vr square. That is the time. Now what? How much angle the person should travel? So sine theta equal to Vr upon Vm, or we can write theta equal to sine inverse Vr upon Vm. So here are two cases, that is based on Riverman problem. Okay. So is there any doubt? Then ask me. Otherwise, it is okay. Okay, students. Bye bye. Take care, all of you.